Hi, let us see this problem today. A body of mass m is projected at an angle theta to the horizontal. The projectile at the highest point breaks into two fragments of equal masses. One of the fragments retraces its path to the point of projection. The velocity of the other fragment will be. So these type of problems should be solved using the concept of conservation of linear momentum. So here basically the situation is like this, that a bomb is being fired, it reaches its highest point, and this bomb breaks into two pieces. Let us say the bomb mass is 2m. So one at the highest point, what is the direction? The bomb will travel only in the horizontal direction. So one piece goes retraces its path, means it goes in this direction. So you know that if the bomb was activated with u speed, it will have a horizontal speed everywhere as u cos theta. Let us say it is making theta degree, theta angle with the horizontal. So this initially, like initial momentum, P initial will be equal to P final. Initial momentum of the system is equal to 0 only. Now what about the initial momentum of the system? You activated a bomb with 2m mass, and at this highest point, the momentum in the x direction, momentum in the y direction will be 0, but in the x direction you will have mass into velocity 2m into v cos theta, because it is going in this direction, is equal to now this bomb is broken down into two pieces. One is m and another is m. One piece is going in this direction, another piece we don't know in which direction it is going. So we'll write here m v cos theta. It is retracing the path. If you are calling this as positive, this will be negative, so it will be minus mv cos theta. This we are talking about the final momentum, and the second piece will be mv. Okay, so we can cancel out this m here, and you take this v cos to the other side, we get 3v cos theta is equal to v. So the speed of the second fragment will be 3v cos theta.